Welcome, Ted.
You can definitely tell that a marketer wrote that, not me. Just a little bit about myself. Like was mentioned, I do work at DataRobot. Prior to that, I was a director of advanced analytics for Liberty Mutual, which is a large insurance carrier. Before that, I was at Amazon.com. One of the things I did while I was there was launch a social media group that supports customer service and social media channels. And that was really my first exposure to text mining. The reason I personally really enjoy text mining is that it is a very messy problem. It's very challenging from an analytical perspective. And we're surrounded by it, right? As my wife says, it's the math of talking, and those are my two favorite things. So, I will start my presentation with a shameless plug. This is coming out in the summer. I said, oh, you know, I wanted to have a woman on the front, kind of like my wife, and then they made like an angry, kind of frumpy-looking woman. So I'm not going to say that to her, I think. But that's coming out. This workshop encompasses probably a little bit of the first chapter and a little bit of the second chapter out of about 10 or 12 chapters. So if you like this sort of thing, you want to get more into it, specifically with using R as a language to do it, this might be of interest to you. First, just going to talk about what is text mining. So this is an introductory workshop. So just going to talk about some basic principles in text mining, get to very basic keyword scanning and cleaning. Then we're going to do frequency counts, dendograms, and some word clouds. Kind of, you almost have to do word clouds, even though they're completely overused in my opinion. And then finally, the last things we'll do is what I consider a little bit more nuanced, a little bit more difficult possibly, topic modeling, and then using OpenNLP. So text mining lets you drink from a fire hose of information. It's really hard to make choices when you're draw insight when you are presented with a lot of text or a lot of information. It's almost overwhelming. It's very hard because it's unstructured. It's very individualistic. There's different lexicons. There's different ways to describe the exact same event. And so this is something that I like. This is a picture of San Diego Bay. It's a satellite picture from Google. It has social media geotagged pictures on it, and it has traffic information. If I were trying to give someone directions in this area of the country, and this was the only thing I had, this would be very difficult, right? And so you have to use something to distill down to exactly what you think would be appropriate and distill meaning from it, right? And so if I were to give you directions based on this is much easier, right? We can now see the streets. We've removed all that information to get at what's underlying so that we can make it useful. Text mining in itself is actually, the way I approach it, is very much this type of workflow, where we first have to gain some subject matter expertise and define our problem. A lot of times people that do text mining kind of love the thrill of it and kind of the parlor trick of doing it, but they don't really ever tie it back to an actionable insight for the business or something that's like valuable to the enterprise. So I think that first box where you're trying to define your problem is extremely important. But the overall flow is that you take, once you have this defined problem, you start with an unstructured, in this case, amount of text, and you have to apply structure to it in order to reach an insight or a recommendation. And you know, text can come from all sorts of places, from within the enterprise and without the enterprise. So you have blogs, articles, social media. If you define your problem in a particular way, that will also help you define where you need to go get your text, right? And then organizing it, doing some feature extraction, doing some analysis, and hopefully that leads you to an insight or a recommendation. And just kind of walk away from the sense of a good text mining project goes from this unorganized state to kind of an organized state to draw out some sort of conclusion. Within text mining, there's actually two different approaches. There's semantic and syntactic parsing, and there's bag of words. The majority of this workshop is going to talk about bag of words. The reason for that is it's very approachable, very easy, and then the very last part of it, we do a little bit of syntactic parsing. The difference is that in syntactic parsing, we actually do a part of speech tagging, where you tag something as a sentence, then here we might tag it as a noun phrase, tag it as a verb phrase, you tag it again as, like, let's say, a named entity in LeBron James. You have a verb, an article, an adjective, and a noun. So you're collecting a lot more rich metadata, but because of it, you're actually, in terms of modeling and things like that, it's very data rich and can be computationally intensive. Versus a bag of word style just tokenizes it in some way. In this case, I tokenized it with a single word. Word order doesn't particularly matter, and we're just going to look at, in some cases, frequency or an inverse frequency. So there's definitely challenges in text mining. I think someone had shown a Gartner hype cycle in one of these earlier speeches. I would probably say that text mining is probably in its trough of disillusionment at this point. It was definitely overpromised, where text was 80% of what's sitting in enterprise data stores. So it must be a very valuable piece of data that we can extract all sorts of value from. The reality of it is you can get incremental value from it. You get things that reconfirm and give you credibility. If you're using all customer service surveys, you have more credibility than someone who simply samples them. And so what I would say is there are definitely challenges within text mining. There's definitely this notion of compound words or tokens, right? So if you say something's bad or something's not bad, completely different meanings, right? You have disambiguation, the example there, I made her duck. Well, that can mean a lot of different things to a lot of people. I cooked waterfowl to eat, I cooked waterfowl that belongs to someone, I created a duck, I don't know. And then there's also the verb duck, right? So there's a lot of disambiguation that has to happen. And so you also have to bring some subject matter expertise and understand that because of these challenges, things are very difficult and it's not black and white. And then my favorite is actually cultural differences. So I come from Boston, so when people say it's wicked bad, wicked is actually an amplifier. So wicked means that it's really bad. And if I said that here, I assume that would be like considered pretty not good of a situation. And I will say that text itself can be very overwhelming. When you talk about big data, people are creating quite a lot of data, textual data, and it comes from a lot of different places, right? So we have books, PDFs, blogs, websites, whatever. The context and the channel in which you collect it is very important to understand. Twitter has a completely different lexicon than, say, even Facebook, right? The use of hashtags definitely is different and more prevalent, let's say, in Twitter versus Wikipedia, right? Certain things that aren't even words in normal English language are words in the Twitter sphere, right? LOL, SMH, things like that are absolutely words. So you have to understand, kind of from a data integrity standpoint, where you're grabbing your text from. Make sense? So I will be walking through some very basic scripts, outlining and showing you guys how to do some things. I learned doing this talk at ODSC East, it's probably best if we walk through them, and then there's a link at the end to download them all. If individuals try and run them themselves during the talk, that's absolutely fine. What I would ask is don't raise your hand and say, I can't get our studio to run. Kind of makes things challenging. Most of the scripts follow this very linear path. It makes it very easy for you to understand, hey, we're going to set a working directory. I just, old habit, like to do it explicitly. We're going to load some libraries, make some custom functions, specify options in our environment, read in the data, perform analysis. And then, to be honest with you, I'd like to make visuals. I feel like human beings consume information visually more so than in table form. So a lot of what we create, both will be a data frame, but then we also will create a visual. In terms of setting up, so obviously, if you're here, hopefully you've heard of R and you want to, if not already, have it installed. That link, including the Kwartler, which is the collection of documents we'll be looking at, that short link will actually take you to an Amazon page, which might be confusing, but there you'll have a folder where you can download those things. And then the first script can take a while, and that's why I suggest we don't do it as a group of 50 or however many are here. And that's where you're going to install all these libraries. I see people taking a few pictures, so I'll make sure I wait a sec.
Are these slides?
Yeah, the slides will be in there as well. In fact, candidly, you could probably just leave once you get all this stuff. So. Are we good? You guys good with pictures of that? 2 more, okay. So I will say that a fair number of these are referencing tweets that I pulled, just snapshot like in 2013. Twitter demographics skew young, there's a lot of profanity, so if that offends anyone, I won't be offended if you get up and leave, then find me afterwards, we can get you more clean text. The reason I like Twitter is it's super messy. People are terrible at spelling in Twitter. It makes it even more exciting and challenging to do topic modeling and things like that in Twitter. So we'll get into one of the first scripts. Let's see, I'll make this a little bit bigger, hopefully, so people can actually see it. So probably a lot of you are aware that there is a Twitter pack. There's two Twitter packages within R. The twit R one with the capital R at the end, it has a very nice function where you can go call on a search term and then just go create a data frame. That's what I did here. I pulled 1,000 tweets. They all mention Chardonnay, but you also get a lot of information. So here's the actual tweet under this text column. You get a lot of information that's like not all that interesting. So we have to be careful that you're not just grabbing text and using whatever is returned like in an API. So in this case, just keep in mind that we're only going to be looking at this text column and we don't care that it was favorited or not. I'll go ahead and close that. So generally what I like to do is start with a little like pseudocode so you understand the functions themselves. So back in Unix, now I guess 35, 40 years ago, grep was created. Grep is still actually very useful for finding string patterns. So grep L, which is that first one, stands for logical. So it actually returns a logical true-false, whether or not that string pattern was found. So what you actually want to do in the grep L function, we'll do this in the script, or I'll show it in the script. You actually pass along a pattern, it's going to search for it, and it'll just return a true-false. What's nice about R is that it will automatically understand in that Boolean that true is 1 and false is 0, so you can actually do mathematical computations based on that. Grep, without the L, you drop it, functions the exact same way, but instead will return the actual position in your corpus for that pattern. So let's say we were searching for the word pattern. The first tweet would have it. In this case, it looks like all of them have, with the exception of one false in there. But in grep, it would say whatever pattern we were looking for. It looks like the 4th tweet, the 214th tweet, and so on have them. There's some follow-on libraries that are very helpful. Stringy and Stringer are really good. One that I particularly like within the Stringy library is string count. So instead of just getting was this pattern present once, or exactly where it is in your document collection, this will actually count the number of times it appears. So I don't know, like if you go 12 zeros, 13 zeros over, whatever it is, you see that that pattern appeared once. Had it appeared twice, that would be marked as a number 2. So essentially we're doing keyword scanning, but there's like 3 different ways to do it, and it depends on what you're trying to do. So let me go into R. Man, that is pretty gnarly. All right, so I like to start all my R scripts with headers. You guys will be able to download this. My Twitter handle is on there. Just tweet me if you have questions or if it fails. Sometimes the packages don't like to play nice. The first thing I'll say is R's default behavior is that strings are considered factors, which can be insanely annoying. So on every one of my scripts, I set it to false. Because if you just need to do it sometimes, you'll end up forgetting and then you'll run into errors, you won't understand why. It's just easier to do that. The second one is we set our system location to all. There's a lot of different locations you can set it to. By setting it to all, you actually minimize the chance of getting errors. So again, those are 2 functions that I set, or 2 options I set in my global environment, and that helps me later. Let's see. So in this case, what I'm going to pull in for this keyword scanning is just, we're going to bring in the stringy library, and we're going to actually look at the collection of tweets that are mentioning coffee. Oh, helps if I set my working directory. Right, and so you can interact with your text, right? So the actual field we're looking to interact with is the text, right? And you can see it returned 1,000, like retweet at the movie sticks, something. What I'm going to do is first execute this line of code. We've actually created an object. Can everyone see that? I guess it might be a little hard, sorry. the coffee object gets created, it's actually that logical return, so it returns that vector. And I'm also going to do the same for Starbucks. Now I'm looking for Starbucks. The last parameter in that function is whether or not it's case sensitive.
Ted, sometimes when we flip the screens, you take your operating screen and throw it hot.
Like that?
You can actually flip.
Come on, man.
Carriage returns too. You can give some carriage returns. So,
Oh yeah, nice. Does that work a little better? I don't know how to flip it, Kurt. I'm sorry, man. So there we've actually created the objects, and we've stored that logical return, right? For here, we've grephed the word mug, right? We're looking at coffee, and maybe we wanted to do a search for mug, and it shows up in the 4th tweet. So these are actually using regular expressions, and so keywords at the top is an object. It's actually the pipe, which is the straight line that's above your return key. At least it is on my Mac. And we're going to look for mug or glass or cup. And so that's what it's going to look for. If it finds it at least once, it would return, in this case, a true, because we're going to pass a grep val to it. And we can just take a, oops, okay, keep skipping. And so let's just look kind of briefly at that object. And you see it's 1,000 true falses, right? And you see, I don't know, 995 somewhere there, there's a true. So it found one of those 3 search terms. Now, like I mentioned, R is smart enough to recognize the trues as 1, so that's actually pretty helpful in some ways when you're trying to do this type of work. You can see that the word coffee appears, we did a sum of the trues, just a sum of that vector, over the number of rows for the text, in this case 1,000, and you get almost 98% showing that coffee's in there. The same can be done with the Starbucks object, right, and it's about 4%. And about 10% mentions mug or glass or cup, okay? So here we're pulling in that function from string, which is the string counts, and from there it should return an integer, and you can see it's counted some of those words. And because it's a count, you can also do that same sum function if you just want to try to understand it. And again, this is a very basic script, just trying to get everyone into the kind of the mode of how we're going to do some of this stuff. And then we can easily create a data frame, and then here I just export that data frame by writing it back to my working directory. So I'll stop there very briefly. I know that's very basic stuff, but at this point, does anyone have any questions? No? Okay, cool. Okay. So remember this, the 3 chevrons, the purple chevrons there at the bottom, that's where we're actually taking this unorganized state and applying very strict rules that are repeatable and auditable, so you can follow things and track things over time, which can be helpful. And in this case, we're using R to do it, right? So here is the tweet. Tomorrow I'm going to have a nice glass of Chardonnay and wind down with a good book in the corner of the county. There is an emoticon there. I actually chose to remove it altogether. That would be a separate type of analysis. You can look for those types of things. But in this case, very often in bag of words style text mining, you want to apply transformations to your text in an effort to aggregate terms. So here we're going to remove some punctuation, remove extra white space, remove numbers, remove lowercase, and remove what's called stop words. So stop words are very often occurring words in the English language. By default, there's like 176. That's like articles and pronouns like he, she, it, and things like that aren't very insightful and kind of get cluttered in the way if you're doing bag of style text mining. So it's good to often remove them. And one thing I'll add, and I'll show a little bit later, is it's very often the case that you will want to remove custom stop words. So when I was at Amazon, if you did a search for Amazon, you'd get quite a lot of tweets returned, right? But you may want to take it a step further, and if you were analyzing all those tweets, you would want to remove the word Amazon because it's so often in your corpus that it will skew all the rest of your results. So after you do all of these transformations, you're left with a tweet that says, tomorrow going, nice glass, Chardonnay, wind down, good book, corner county. It's essentially getting to the same kind of gist of that tweet. And in doing so, we're able to now aggregate terms. Because really, if I had another tweet that had lowercase tomorrow in that tweet, the word tomorrow just happens to be the first letter, and that's why it's capitalized. Essentially, if I wanted to analyze that, that's the same word, so putting it through those transformations can help with that. So here, I'll talk a little bit about a little bit more bag of words style methodology and more pseudocode. So a V corpus is a volatile corpus, and that is, a corpus is a collection of documents, and it's volatile because it's held in RAM. If your battery goes out, if you close R without saving your session, that corpus or collection of documents is lost. It's, you know, probably saved somewhere in your working directory or something like that, but it's not held in R's memory. There is a different function called P corpus where you can create a permanent corpus that saves it to disk. But I like V corpus. TM map is a way to apply transformations when we're doing this, these text cleanings, right? Like removing punctuation and so on. Calling the function get transformations will list common ones, and then you can always create new ones. We create a very small one later. So really, two text mining kind of glossary terms I want you guys to take away is a corpus is a collection of documents. If you have multiple corpus, that's called a corpora. You'll hear text miners talk about that and refer to that. And then stop words I already talked about. All right, so I'll go ahead and open up. This will be the first actual script where we're going to clean the document, in that case apply those transformations, and then we'll do some frequency counts. So the TM package I just loaded, which stands for text mining, it's a very popular text mining package for R. I'll leave this. So, but one of the shortfalls of this package is there's this function called, it's actually I think in base R to be honest with you, there's a function called toLower, and that's where you take all your, no matter the case, and you just make it lower. The problem is if it encounters an emoji or something like that, it throws an error, and it's not recoverable in the sense that it doesn't just return an NA, it will just return an error and stop your script. So we actually have to wrap it, so there's another function I posted online that someone had written where it's called try to lower, and what essentially happens is it allows, if it encounters an emoji or a non-English character in this sense, it allows it to just move beyond it and just create an error, but still allow you to move forward. So I'm going to go ahead and create this slightly customized version of that transformation.
Question?
Yes?
Is it easier to remove the punctuations and other things before doing the toLower?
Is it easier to remove punctuation before doing toLower? I suppose it could be. To be honest with you, if you remove punctuation through the function remove punctuation, that doesn't change the casing at all, so I can't imagine it would make a difference one way or the other. But I hadn't.
mentioned because it said about error for emojis. Would that remove the emojis in that?
Yeah, if the emoji itself is encoded as like a parenthesis with like a smiley, but if it's not, right, and it's an actual Unicode U plus 528 inside of brackets, it could be a problem. So there again, I think it might matter in some sense. I actually create a clean.corpus function where I'm passing in the corpus, and then we're going to remove the punctuation, stripping extra white space if there's like extra tabs in there. We'll remove numbers, and then we apply that customized toLowering function. And then finally we remove words, and specifically our custom stop words. And then afterwards, we're going to pass back this clean corpus, okay? The reason it wouldn't really necessarily help you in this script to have this function, because we're only working on one corpus. But if you're working on multiple corpora and you had to like type these out every time, this would be, or copy and paste, this would kind of become a pain. So it's better to just wrap it into a function. So I'll go ahead and create that. And then here is where we actually have our stop words, right? So if I just called on the English stop words, so I take it back, there's 174 of them. You can see that these do occur often and they aren't very, very helpful. And so what we actually do is create a vector of words by combining those words with our customized ones. In this case, I just threw in LOL and SMH. And we're bringing in coffee, so I probably want to remove coffee. I don't know that I do or not, but I will. And then, so here we're actually going to create that. We're going to bring in our text, same as before. What's interesting about when you actually go to create a corpus, you can, you also may want to keep some sort of metadata about it, like who the author is, or a unique ID, right, like a customer ID. So here, in order to do it, you actually have to tell R explicitly, read this table with, and the content that's going to make up the corpus is our text, text column, and the ID itself is actually an ID column. So it's important that if you want to capture that metadata and you can start to dissect it, that you still keep it by creating that custom reader. So we do that, and then ultimately I say, hey, create a volatile corpus using a data frame source, in this case, my text. And the way I'm going to read it is that I'm going to specify that very particular custom reader. And so now we actually have this 1,000 content, or 1,000 tweet, or collection of documents volatile corpus. And we're going to go ahead and clean it. It takes a little while because, again, this is all held in RAM. So it may make sense to like put an RStudio installation over at DigitalOcean or something like that if you're working with quite a lot of text.
Document is considered to be a string.
In this case, it's each row 1,000 tweets. So the question was, is a document a string? In this case, it is. But a document could be an entire article from The Guardian or New York Times. So if we had 1,000 articles, each one of those would be a document. In this case, these are very short documents. They're individual tweets. Does that answer your question?
But data representation-wise.
Oh yeah, these are all character strings. Yeah. Yes.
I know it's kind of a hard thing to pin down, but what would you say is the thing that, or how big would you say makes it large versus just doing it local?
It's all, you're completely hamstrung by your RAM, right? So you could use, I think, the SOAR package, which is pretty decent. I haven't experimented too much with the P corpus. You could probably get around it a little bit. This MacBook has 16 gigs. It'll chew through this really easily. My personal laptop has 4 gigs, so it's garbage, right? So I would say that you have to, and what you'll get is kind of a cryptic error, I think, something around like cannot allocate vector something memory size. So you'll know when you're hitting that limit, and so you kind of have to do some tricks, whether you go to DigitalOcean and open up a cloud instance briefly, you reduce the number of text that you're working on at once, that sort of thing. So let me just quickly go back to the presentation. Does that answer your question, by the way?
Yeah.
Okay, cool. Yeah. Right, so I just walked you guys through this, right? Like the to lower, where the to lower shows up again, our custom stop words and that custom reader. What we're going to do in a bag of words methodology is actually create one of two matrices. They're actually transpositions of each other. One is a term document matrix, the other a document term matrix. In the term document matrix, every individual term, in this case what's called a token, is on our first column, and each tweet would go across, in this case, all the way to 1,000, so you'd have 1,000 columns. And in this case, we're not doing anything fancy in terms of weighting or anything like that. This is actually just a frequency count of those terms. The transposition of that would have tweets, so you'd have 1,000 rows by however many individual and unique terms there are. So what I would say is these matrices are very large and very sparse, meaning that they're mostly contain zeros. And if you think about human language, humans describe things in using completely different lexicons. So you may say that this presentation is good. Kirk over there would say, oh, it's not as, it's okay, right? Now generally they're kind of saying the same thing. There is some sort of review of this presentation, but they're using different words altogether. So what I've done is actually tried to make this from that concept into something that's held in memory and actually real for you guys. So I'm going to create both the document term matrix and the term document matrix. And then I'm going to just treat them as matrices. They're held in a different class, a simple triplet matrix, I think it's called. So that is kind of a pain to work with. But here I'll show you. So now that they're actual matrices, I'm going to say, what's the, oops, right? So in this case, the document term matrix, there's a, you guys might not be able to see in the back. If I call in the dimensions of that matrix, there's 3,179 unique individual words that were just cleaned, and there's 1,000 rows or 1,000 documents. And if we wanted to actually look at them, so this is a very small subset that I've indexed. Because we held that custom reader, we've still under the documents, those are the unique Twitter IDs on the left, and you can see like the word Venti, version, investor, via Victoria, and Victoria Lloyd happen to be the words at this exact point. And you can see that the third tweet of that first kind of section actually had the word Venti in it once. The transposition of that has, in this case, two documents that I'm showing. Again, it's way bigger than this, so I just am indexing to this point. And you see the terms down the left-hand side, you see that same word Venti is in that first tweet. Yes?
Just to clarify, you created an inverted index, right? I know in Solar they describe their search via inverted indexes, where they just relate their documents to words, and then when you look at the documents, you then like index your words, but then you look at the words and they're now indexed to documents. And
To be honest, I don't know the answer to that one, man, because I don't know Solar.
that's the only one that's something.
Yeah, you know, you probably are right, man, to be honest with you. I have no idea, to be honest. Yeah, I guess I'll just have to read more about that. Yeah, I'm not sure. So essentially, that's all this script is doing, is helping you. The goal of this script is not actually fancy analysis, just to get you to understand what that backwards methodology is creating. Because all the analysis from this point on is going to be based on these two matrices, or one of these matrices. Any other questions that I might not know the answer to? Yeah.
I know you can join term document matrices together, so can you join document term matrices?
Yeah, I assume so. Yeah, I assume you can interact with them the same. Even if you could join the one, you could just transpose them, like the larger one. So I assume it's possible. I've never actually done that, to be honest with you. I just always try and find like beefier and beefier machines to work on.
Question?
Yeah.
You used a custom reader, right, to read your corpus?
Yes.
Is there anything specific you did, or can you use some inbuilt readers?
No, so the custom reader is just telling R how to explicitly, because if you don't do that, it's not going to capture like an ID. It'll just say document 0, and just so you lose some information. So it's the default like parsing of read.csv is actually how we read in the characters, which can cause encoding problems certainly. But in that case, I wasn't really manipulating the data. I was just saying this is the text column and this is another column of metadata that I want to capture. That's all we were doing in that custom reader section. Okay. So again, maybe not wildly interesting because all we've done at this point is organize some things. So now we'll get to actual, somewhat interesting things, I think, in my opinion. We're going to create what's called a dendogram and do some simple frequency analysis. So, good. So again, I'm not going to spend too much time on this because it's very similar, but this time I'm bringing in ggplot and ggthemes. Ggthemes is a wrapper for some of the aesthetics of ggplot. I don't particularly like default ggplot. I'm also very lazy and don't want to explicitly say all of my different like color palettes I want to use, so I like ggthemes. Here we're creating that clean corpus again, same as before. We're kind of building on this. I'm adding a new function called, it's call_lab, but it's actually like a color labeler, and I'm going to ignore it for now. We'll get back to it. But I have to list, or I do list my functions at the top. This corpus is actually 1,000 tweets, oops, mentioning the word beer. And we're going to go ahead and create our matrix. Right, in order to extract the term frequency, now that it's organized into this matrix, it's actually very, very easy. All you have to do is call a row sum. So I go ahead and do that here. And we'll just look at that. You can see there's some missed encodings there, like the 8.5, that's actually an @ symbol. right? And so that would make some sense, like for whatever reason, we're having trouble with it. I fixed that in a later script and I'll show you guys that, but I didn't now. But you can see like the tail of that, it starts with all Z's, right? And so zombies in there 130 times, which is kind of unusual. We'll explore that a little later. I do write in there how, if you wanted to export that data frame, but generally I like to create visuals. I mentioned before I really enjoy consuming information visually. And so what I'm doing here is actually creating a subset of that data frame of any terms that exist at 90 or more times. Because right now there's 3,000 or so individual terms. You can't really build a very compelling visualization with that. So you might have to play with that with your corpus to say, do I want 30 or 40 or 100? It all depends. So I'll go ahead and do that. Oops, helps if I make that data frame. Then I order it, and I treat them as factors. The reason I treat it as factors is it allows ggplot to sort them in a way that I think is more aesthetically pleasing. Then I call on ggplot. Are people familiar with ggplot, or do you want me to go into? Okay, cool. So I won't go into it too deeply. Oh man, that was pretty gnarly. So interestingly, right, so I created this using the gdocs theme within GG themes, again, because I'm lazy and don't like their default. And so you see like the word coffee shows up even though we're talking about beer tweets, right? So that's pretty interesting. Avid, geek, fanatic, specialist, zombies, there's that 130 that we saw before. It's very unusual. These are words I probably wouldn't, bacon maybe. People talk about beer and bacon a lot. But these are words I may not have associated necessarily with bacon, or excuse me, with beer. So of course from there, like, okay, that's relatively interesting. What I like to do in this very simple type of analysis is do my frequency analysis, find a word that's kind of interesting and unexpected, and actually look at the associations with it. Association is the text version of correlation. But instead of -1 to 1, it's 0 to 1. Because virtually every word would be negatively correlated because they're just so diverse and likely not going to show up. So essentially, we're going to be looking at the associations of the word zombie. I picked 0.3 or more. Correlations or associations in text generally run pretty low. So 0.3 is actually fairly high in my practical experience. There are times when you can do more, or have it much higher, like 0.8, 0.9. So essentially what I'm doing is finding those associations. So in this collection of documents, the word zombie is associated with things like geek, specialist, coffee, aficionado, avid. So this hipster I could see, kind of unusual. This can sometimes give you unique insights and things like you already are surprised maybe by a particular word or group of words, and to start looking at those kind of associations. We get a little bit more into doing what's called a dendogram a little bit later. But for now, like this is a very rudimentary, like, hey, we're trying to figure out what's going on in this. Oops. Skip the line. All right, so again, I'm gonna call ggplot. This time, aesthetically, I chose something a little bit different. And just plotted it out. Well, it gets a little cut off there. And so just plot it out so you can see what those associations are. So it looks like zombie, geek, and beer are really pretty often associated in this corpus. Let me go back to the slides and show you guys what's called a dendogram. So here, this is what I just showed you, right? The frequencies and the bar plot. There's zombie that we just looked at. And then you see the word geek there at the bottom. It's the most highly correlated. So I actually pulled a tweet, and someone wrote, alcohol geek, avid TV buff, friendly beer aficionado, coffee guru, and zombie junkie. Why someone would tweet that, I'm not sure, but that is an example of all those bizarre words kind of all being together. So the next thing we're going to create is called a dendogram. A dendogram is a hierarchical cluster, and based on frequency in this case. So essentially it reduces information. If you have a population, you take an average, it tells you something about that population, but you've reduced information, right? So it's an information summary. A dendogram works similarly. So when you do this, some word clusters actually start to pop, and that can help you draw out themes as you're looking at it. So in this case, this is an example. Let's say we had 3 data points, and it was Portland had rainfall of 43.5, Boston had 43.8, New Orleans had 62.7. A dendogram based on this table of data may look something like this, where Boston and Portland are collapsed to 44. They're very similar. And New Orleans would be like a standalone node on that cluster. So when we applied that same methodology, this hierarchical clustering, and we have to cut the tree. One thing I do want to point out is, you see here in this TDM2, I've created a second term document matrix. I'll go ahead and compare them so you guys can see. Like the TDM2, after we've removed stop words, the original term document matrix has 2,488 distinct terms. If you try and plot this, that's going to be way overwhelming. I commented out right here that we want about 40 terms, and so there's a function called sparsity where you're trying to collapse it and just get to the most frequent terms. So here I create TDM2, and I'll show you what that looks like. So TDM2 goes from like 2,400 words to 45. So you get a sense for, like, we've totally collapsed a lot of information, but it's going to make our dendogram first plot, because if you tried to plot 2,000 points, it takes a while. And then secondly, it'll actually make it useful because you can read it. Don't worry, it doesn't really look like that. So this is the base R plot for a dendogram. Hopefully you guys can see that. And so you can see, like, I find this kind of challenging to read. It's kind of, all the words are different heights. It's not aesthetically pleasing, but it does get a point across, right? You can see specialist, zombie, avid, coffee, geek, and fanatic are its own kind of cluster over to the right. And that is supported by both what we saw in the frequency and in the association analysis. So what I like to do is actually plot it using that color labeler and with some improved characteristics aesthetically. So what we've done is actually change the shape of it and drop them all down. Yeah, go ahead.
How do you determine where to go the tree?
I just do it through trial and error, to be honest. I mean, text is so messy that, like, it's a very iterative process. I'm sure that someone somewhere has a more nuanced opinion, but literally that's how I do it. Is like, I'm trying to extract meaning, and so I'll look at a tree and say, does that triangulate with A, what I know about the business problem, or B, is that truly unique and insightful, in which case that is something I want to capture, but maybe rerun the analysis on a different report, maybe from a different snapshot in time, see if it reinforces it. So I just do it through iteration. So this, to me, it's a little cut off, but is more aesthetically pleasing. You still get the sense that there's this cluster over to the right. There's a lot of garbage that we don't really care about, kind of in the middle, and then maybe an interesting cluster on the left. And so, like, you can see words like problem solver are right here. They don't appear that often, but when they do, it's kind of similar frequency, and that would make some sense from what we know about language, right? The word problem solver does show up often. Or often together. So that is a dendogram. Let me go ahead and get back to the presentation. I can't stress enough, like, how often you have to kind of tune that sparse parameter. It goes out like 6 decimal points. And like I said, shoot between 40 and 50. Anytime you get beyond that, it starts to get really cluttered, very difficult to deal with. And then, again, sparse means that it's mostly zeros. Visually appealing. Okay, so we'll do a simple word cloud. But I'm also going to introduce bigram tokenization. So to this point, we've looked at individual words. We're just cutting on the spaces, right? And so we're looking at individual words. It's very often the case that you'll get more feature enrichment when you are actually capturing 2 words at a time, or sometimes even 3. So the way, for instance, at Amazon, I think at the time I was there, the word Amazon was in social media, or at least in Twitter, something like 20 million times a month, right? And that can be very difficult. So what they would do to identify customer service related tweets, they actually do unigram analysis, which is individual words, bigram analysis, and trigram analysis. They model all three in order to identify what is likely to be customer service related. So I'll go ahead and open our, go ahead and open our simple word cloud function. We do our custom stop words, and then I'll show you guys this bigram tokenizer. And so what we're actually doing is making what's called n-grams, and we're splitting on the two, and that's what this function is doing. And then when we create our matrix, that's how we actually have to specify use this, because the default is a unigram, or one word. In this case, we're going to bring in Chardonnay, and we're going to do the same thing we did before with the data frame with our custom reader and create our corpus. This line is where we actually have our term document matrix, we pass in the corpus, and we're actually going to tokenize it, in this case using that bigram tokenizer function. And then I split it, or reclassify it as a matrix. Again, I'm pretty lazy. I don't like to specify colors explicitly or color palettes explicitly, so I like to actually use the functions of Color Brewer. In this case, there's a line in there that will produce all the different palettes. It's a little hard to read up there, but you can say like, oh, I really want to use the BRBG, which is brown and blue-green, or something like that. So you don't have to do this line of code, this display.brewer.all, but I like to do it. And then I create this brewer palette. In this case, I specify just give me the blues. And then I drop the two lightest colors and then create our word cloud. So unless I skipped a line, I think we're okay. So it's cramped here because of plot size. But essentially, in a bigram tokenization, we actually capture the words Marvin and gay as a single token. And that's something that's very surprising and we wouldn't have known was in there. And had we done unigrams, the word Marvin would be disconnected from gay. Does that make sense? So we actually had to bigram tokenize it, and that actually is extremely frequent. And we're specifying that color palette there in the word cloud. What I will say is, like, I'm not a big fan of word clouds, but they are very compelling for some reason to senior leadership. It's not even like a nuanced, very difficult analysis. When I was at Liberty Mutual, we got 50,000 customer surveys in a month. We did some NLP, very kind of cool topic modeling. Ultimately, the word cloud won the day just by doing frequency analysis. The vice presidents really liked it. So it gets fairly interesting a little bit later when you start thinking about word clouds with more corporeal, more than one. And the word cloud package actually does this. So if you call a word cloud function, you'll get that single corpus frequency analysis. There's the commonality cloud. It's been my experience that commonality clouds are not at all useful, but it does exist. And then the comparison cloud actually can be very useful. We did an analysis at Liberty Mutual where we took all of the Glassdoor.com reviews of Liberty and State Farm and Allstate, and we did the commonality and comparison clouds. And it turns out everyone complains about money. I guess no one feels like they're being paid enough. But in comparison, people not at Liberty, one of the other two, I forget which one, actually was much more concerned about career advancement, right? And so we went back to our HR and said, hey, it looks like people are comfortable with our career advancement versus our competitor. Maybe that's something you should focus on in recruiting. So that was a useful insight that we gained by using the comparison.cloud function. Those are like a little bit more interesting, I would say. So I did create another script called the other word clouds function. Go ahead and do that. So this one's very similar to the last one, so I'm not going to spend too much time on it. String is factors. Let's see. Oh, the one thing I will say is I'm bringing in more than one corpus, and just to illustrate how the clean.corpus function absolutely helps you, instead of using that, I actually did every single one individually, which is like a total pain and not good syntax or good R coding, but it shows the pain of not using good custom functions. So I'm going to bring in, Chardonnay, coffee, and beer. Earlier, we saw that @ symbol was encoded as bracket 85 close bracket. The way to fix that is actually this icon, and we're just going to specify Latin and ASCII, and we're just going to switch them. It's very helpful to do that, especially in Twitter, because people use all sorts of crazy characters that R has trouble reading. We will 3 times over create a virtual corpus or a volatile corpus. And then we're going to do all of those transformations in order. Here's where we're actually going to stack them and create a larger corpus. And then we create a term document matrix. And again, treat it as a regular matrix. And then we're going to label that term document matrix. And I'll show you actually, finally, ultimately, what all these lines of code have done. So here you can see we now have the Chardonnay, coffee, and beer, corpora. And we have the terms going down the left. And you can see the word avid shows up in beer, but not at all in coffee or Chardonnay. And those other words are appearing at least once. So this time, again, I did the color brewer because I don't want to make my own, so I just chose the purples. Let's see. Drop the 2 lightest colors, and we're going to do a commonality cloud. This is not going to look rendered very well, but it's not all that interesting, right? Because we know that all 3 of these are drinks. And also, I want to specify I'm not much of an alcoholic, and drinking beer and Chardonnay and coffee seems like a bad idea all at once. Just an easy way to get text, right? So again, this is that commonality cloud. These are the words that they have in common. It's not all that insightful, because in this case we knew drinking, and people love it and like it and whatever. And then the comparison cloud, I think, is actually much more interesting. Oh man, that looks, I'll show it in the presentation. I think it looks better. Yeah. Right, so this is the commonality cloud, and you can see it's not all that insightful. But here you can see, like, apparently people consider themselves scholars and fanatics and geeks around beer. And you can see Marvin and Gay, we only did unigrams again, so you can see they were disconnected, but they are there. And then obviously people when they're talking about coffee are talking about coffee cups and morning, and I think like Starbucks is in there, Iced is in there. So these are things that we already knew about these drinks, but that's what this type of analysis can show you, is like where they're actually diverging. And that can be useful, as in the case of that glass door project we did. So I'll stop there briefly before getting into something I think is more difficult, but hopefully pretty cool. Any questions to this point?
So you said that with the comparison cloud, you saw that everybody was complaining about their salary or whatever between the 3 different companies. How come you didn't see that in the commonality cloud?
No, that was the commonality cloud. The comparison where they're separate, that was, I didn't see it. So if no one says that they complain about career advancement, those words, that lexicon didn't show up in Liberty Mutuals, and it only showed up, then you would see it. You would see it, right? So that's what it's doing. Does that make sense?
Yeah.
Okay. Yes.
Yeah, I'm not sure if I missed it, but are there any particular packages used to extract from the Glassdoor information?
Actually, yeah, no. So the question was, how did I get that Glassdoor information? I actually used third-party software. I assume you can do it with RVest. I just, at the time, RVest wasn't around, so we just made it, like, did it through third party, using InSpider or Power Search, I think it's called. Yeah, any other questions? Yes?
Do you know how an Indian cloud works, like the economies of the Indian cloud?
I'm not familiar with that visualization, to be honest with you.
It's got, they look at their blogs, and they look at the most commonly talks about team,
Yeah, so just picturing it, that's some sort of either cluster analysis or possibly using like string distance. I could look at it like afterwards, and then we can take a look because I'm not familiar with the visual, but absolutely, I think visualization is a good way to get the points across in text mining. So yeah, afterwards, let's just chat. Other questions? Yes.
You mentioned that the term correlations could be low, yet still significant.
Yeah,
Well,
it's not always significant. It's just that they could be insightful, right? Because significance is a different weight. I would
Is
say.
this because the matrices are usually very sparse? I mean, if we actually remove the sparsity to like 1 to 8, would that affect the term correlations that we get? Or not?
Yeah, it should, right? Because now it's a much smaller, less diverse lexicon. But when you have, in this case, 1,000 tweets created, 4,000 through 3,500 different terms, it's more diverse. So when you're actually working in articles and not 10-word sentences as a document, it gets very, very diverse.
Okay, that's good. So when you do remove sparse and with TDM or ATM, does that actually take out rows or columns, or what does it do?
It depends which one you're doing, but yeah, it will drop the rows according to sparsity, right? Like if you're, it won't drop the documents. The document will just be listed as all 0.
In terms of k-means, I mean.
Yeah, so actually I wouldn't use k-means for cluster. I would use k-medioid because you can get outliers. So the question was, can you use k-means clustering? You absolutely can. It's been my estimation and just practical knowledge, take it for what it's worth, that k-medioids is better. You get, if you have like very unusual words that become outliers, that can skew those clusters. So sometimes k-medioids can give you better clustering analysis. Yeah. I took the clustering out of this because it's an introductory one. I just did the hierarchical cluster. But yeah, absolutely a good method. Other questions? Yes?
Do you use any other features besides frequency often? Like in my mind, I can see sentiment.
Yeah, we're going to get to sentiment. Actually, frequency is like, it's often helpful. It's very easy, right? Given that this is an introductory class, instead of sentiment, cluster analysis or even LDA topic modeling can be very insightful. Yeah. Yes.
This type of work, are there some things that are particularly excels over Python?
Actually, I feel like, and I don't particularly like Python. I do fall on one side of that camp. Yeah. To be honest with you, I have gotten a lot of pushback why I don't do this workshop in Python, because apparently Python is superior at text mining in all regards. So I don't really know how to answer it. I actually like doing it in R. It's all held in memory. I think possibly like the neural nets associated with word2vec and doc2vec are better in Python. I don't do that here because this is introductory. But to my opinion, I prefer R. That's why I wrote the book in R. But the publisher asked me to write it in Python. So. Other questions before I move on? Okay, cool. Good questions though. Good questions. All right, so what we're going to actually do is create a tree map. A tree map is, it represents your corpus in 3 dimensions at once. You can change what you actually want to represent, but here I'm showing you polarity is positive or negative. I'll explain what that is next. The size of the individual article or corpus in terms of its just document length. I just do a row sum on the terms. And then those broader, in this case 5 topics, are created through LDA topic modeling. You can also do correlated topic modeling. And so the end result is, like in this case, I can see like the lower right, it's a little washed out, is kind of like pink-red. There's some negative sentiment, generally short articles from the Guardian newspaper, and they're all related to something in Afghanistan with Saudis, and I was doing a search for Pakistan. So that's a topic that was identified, and you see the bigger articles that are mostly green, those are all about cricket. So it's interesting to see where they're spending their writing effort and how they're talking about things. So I'll explain kind of what's behind the scenes, and then we're going to make this visual. Just to be completely honest and candid, I am still learning about LDA topic modeling. It's latent Dirichlet allocation, so it's actually looking at probabilities of words to identify topics. The topics themselves, each document is made up of mini topics within it. And so if we had a corpus, I like to watch basketball and football on TV. I watch basketball and Shark Tank. Open source analytics software is the best. R is an open source software for analysis, and I use R for basketball analytics. If we had topic A, which was made up proportionally of some basketball, football, TV, and watch, so you'd say, okay, that topic is about watching sports. You'd say topic B is software open source analytics, and it's something to do with, let's say, open source. So let's say we have those two defined topics. As you look at that corpus of documents, you'd say, okay, the first one's all about sports watching, second one's all about sports watching. But if you look at the fifth one, I use R for basketball analytics. It's kind of a mix, right? Because it's mentioning basketball and, in this case, R. And so that's kind of how LDA topic modeling happens. The next one, the next dimension we're going to explore as part of that tree map is actually polarity. So I am not a fan of sentiment. I once had a presentation from a very large company that said, hey, you're in charge of customer surveys. We can tell you if the customer surveys are negative or positive. I said, okay, but the customer told me that they hated our service in the first sentence, or in the first question. They rated us a 1 out of 10. So I don't need your analysis to tell me that whatever they write is going to be negative. I need your analysis to actually give me some actionable insight. And so I'm not generally a huge fan of sentiment. People love it. They think it's like a cool parlor trick, and it is interesting, but very often it's not enough for an enterprise to actually do anything with it. In this case, the QDAT package has a really cool and very easy polarity function. So sentiment is actually the emotion that you're feeling, frustration, happiness, something like that. There are different types of emotion, both positive or polarities related to emotion. So if I win the lottery, I'm surprised and I'm very happy, right? So my emotion is surprise. My polarity is very positive. If I'm hit by a bus, I'm likely also surprised and likely very not happy. So the QDAT package is really, really cool. I would suggest TM and QDAP are the ones that you're going to spend most of your time with. There's a function in there called polarity, and what it's doing is looking at, it has predefined lexicons of a few thousand words, and that lexicon is done through academic research, and it says this set of words are positive, this set of words is negative. It's simply looking for those positive and negative words, but it takes it a step further, and it says, okay, I identified a positive word, now I'm going to look 4 words before it and 2 words after it, and look for valence shifters. And these are amplifiers like, oh, I found good, but right before it is not, so therefore it's not good, that's actually negative, right? So it's not just simply taking positive and negative and adding the two, it's more nuanced than that. And the reason that this works, that you can get kind of pretty decent accuracy for this positive and negative polarity, is that human beings, while I talk about lexical diversity, human beings actually don't use that many words. If you think about it, in your vocabulary, you may know 40,000 words, maybe even more, right? But in a typical day, you probably only use 2,000 to 3,000 diverse words. And there was a linguist from Harvard called Zip who noticed this. He studied many different languages, and even the Twitter sphere behaves in this manner. That's 100 points, the top 100 words used in Twitter among 3 million words. And so, like, the first word in Twitter, the Twitter sphere is barely English in my opinion, but the first word is actually RT, which means retweet. It turns out people are not actually creating their own content that much. That's the #1 word. In English language, I think the #1 word is I, so people, I guess, are talking about themselves a lot. And so when you have a lexicon of maybe 2,000 to 3,000 words, you may be only getting to here, let's say, in lexical diversity, but that gets you most of that distribution. And so you don't need a natural language dictionary to have every single negative word, every single positive word to try and calculate this polarity, especially when you're doing it on large amounts of text. Questions on how polarity is scored? Questions on Zipf's law? Yes?
What about technical documents?
So the question is,
Law versus
in terms of like scoring it?
in terms of word distribution.
You know,
Expand from 10 words out.
what's that?
Just like expand it from 4 words to like 10 words out.
Yeah, you know, the question is very technical documents. There's a language to many professions, right? At least for QDAT, when you're within that polarity function, you can pass in customized words. I assume the same would be true for legal documents, right? Plaintiff, defendant, things like that. That's where it takes subject matter expertise to really do this. What I'm showing you here today is more general sense about the English language as a whole. But absolutely, the domain and channel in which you choose to have your text is really important, and understanding the words that are used is very important because it will absolutely affect this type of stuff. Yes?
How accurate is the polarity function in QDAP?
Well, I mean, in terms of mathematical calculation, it's very accurate. The lexicons themselves are very standard in text mining. They're published at, what is it called? A bunch of researchers watched people like argue and talk about it.
With your own experience.
Oh, in my own experience. You know, I actually think it's pretty good. I just don't know how to like go to a vice president and be like, yup, this was great, right? What I would say is, yes, here's your word cloud, right? I would say it's about 80% accurate, that it's getting in the general gist, whether it's positive or negative, right? Interestingly, I was at Text Analytics World, I guess now 2 years ago, and they did a very similar analysis. It wasn't looking at valence shifters, but that positive and negative just adding and subtracting. And they did it with Spanish hotel reviews and English hotel reviews, and it turns out Spanish people are, or at least in their corpus, not to generalize, are much more dynamic and much more polarized, either positive or negative. And so if you're doing like, so they asserted that yes, it's getting it right, and if you are comparing cross language, you actually have to normalize for that if you're doing this type of stuff. Question in the back.
So does this work with stemming?
Okay, so the question is stemming. So stemming is actually, it's another transformation that's done. Let me first explain stemming and then talk about this. So stemming, if you have the word liked, liking, and the word like, those are all essentially the same word. And so you stem them down to L-I-K. And so the question was, and that allows for better aggregation. So the question was, does this type of scoring work for stemmed words? What I would say is no, and that actually if you're stemming, you have to then stem complete. So you stem liked, likely, liking, and like all down to L-I-K. You stem them, do what's called stem complete, back to L-I-K-E, and then it would work. So I didn't get into stemming because I wasn't sure everyone would know it, but it's a good question. Other questions? Yes?
Does the zip law during a sudden political event or major event, do you see the same kind of...
The same distribution? It's human nature, I would argue. And Zip actually, I believe, argues the same, that no matter the actual language, French, English, right, Portuguese, whatever, that same distribution holds true. So depending on the event, was the question, does Zip's law hold true? I'm guessing that it would. I haven't really studied it, though. Yes?
Does it hold for n-grams?
What's that?
Does this law hold for 5 grams? 5 grams? N-grams?
Yes, but I assume, so the question was, would Zip's law hold for n-grams? I haven't studied it, but I would assume it would, but the height would be different because you actually have the same shape of curve, but the frequencies would be totally different.
How much should I listen to 5 grams?
5 grams?
Yeah, that's from my own little research.
Oh, nice. Yeah, good. Other questions before I...
What was the 5 gram
Yeah.
Zip's law applied to...
Up to 5 grams?
Yeah.
That's
Nice. Okay, so here's an example of Zip's law, or excuse me, the QDAP polarity scoring. So I did this presentation at St. Peter's University, and just save the slide. So I love St. Peter's University. This lecture is good. This lecture is very good. Data science is hard. I like it a little. Data science is hard. If you do the polarity of each of those, the way it's counted out is that love was identified in the lexicon as positive, and because it has 5 words, it's 1 over the square root of 5, 0.447. The text 2, this lecture is good. It was positive, but it's only 4 words, so the square root, so it gets 0.5. Good was found along with an amplifier of vary, so you can specify the weight of that amplifier. The default is 0.8, so that's what I did. 1.0 over the square root of 5, so it's 0.8. Hard and like cancel each other out too in the next one, so it's data science is hard, I like it a little. So because of that, it's 0 over the square root of that entire corpus. And the last one is hard, so you get negative over the square root of 4. Does that make sense? Yeah? Okay, cool. In reality, sentiment is extremely complex, right? Like polarity is definitely dumbing it down. It definitely is in the ballpark. People, for whatever reason, seem to love it. But there's so many emojis. This is Plutchik's wheel of round emotion. This is what I believe psychologists thought emotion looked like. The best visualization I've ever seen around emotion is actually from Kanjoya. It's pretty hard for you guys to see, but Kanjoya owns, I think it's the Experience Project, and it's a couple million people just writing what their experiences are. And it could be my parents are going through divorce, all the way to everyday things like I'm having a cup of coffee. And they've collected all this data, and what's interesting is they have the author themselves tell you, choose what their emotional state is. And so what they've actually done, because they have the same users, and they can track them over time. And so you can see a whole on the left-hand side, as you guys, yeah, left-hand side, happy. So there's a lot of Kanjoya's large corpus is devoted to happy, with all like cheerful and all these other ones, right? What they realize is that if they track these people longitudinally, they go to a state kind of in the middle, mostly calm, and it's a little hard to read, mostly kind of neutral sentiments. And then over on the right, you actually have depression, and then you have like the red ones were actually related to like frustration and anger and all these things. And what I thought was really interesting about it is they actually realized when they did this longitudinal view is that people who are depressed almost never log back in later and say that they're immediately happy. It's actually a journey of emotion through time where very often they get to a contemplative or calm state first, and so on. This is actually what they published at Text Analytics World a couple years ago, and I just thought this is the most unique and likely a good analytical explanation of true emotion. So when people say like, oh, do you do sentiment analysis? It's like, that's a pretty jumbled mess and pretty difficult to do, and took many years to understand. And it's so when you say it's positive and negative, it's really dumbing down the human experience to a large extent. So we'll get into the actual topic modeling script. I think I have like half an hour, so I think we're doing all right. So here I'm bringing in the tree map library, which allows us to create a tree map. I'm also bringing in the portfolio function library that has a function called map market, which is a tree map maker. Allow you guys to just compare the two. There's the QDAP library. Guardian R I really like if you're just testing this stuff out. Go get an API key for Mastery for Guardian R. It's an API call to the Guardian newspaper. You can specify time, and you can specify a search term. I think you're limited to like 5,000 calls a day. You can get a lot of text. And it's not necessarily even that messy, because obviously it's English, first of all, and it's a newspaper, so it's very structured. There's not misspellings, things like that. It's a good place to start. QDAP is really good, like I said. Topic models allows us to do our topic modeling. TM and Snowball is another package. So I'll bring those in. I'm going to do this live, trying to pull in the Guardian newspaper stuff. That could get ugly. I'm not so sure it's going to work, but we'll try. So before everyone's like quickly going to copy down my API key and start using it, I'm going to change it after this. But so here I'm looking for Pakistan, and I did a very short time frame. It looks like it just picked up, I don't know, it's 1 week, and it picked up like 5 articles. I'm going to do some pre-processing where what gets returned from the Guardian R is actually a data frame, and I want to just only use the body of that text. I want to remove the HTMLs, the URLs from it. Remove bracket X means remove anything inside brackets. It's a QDAP function. That's great for removing HTML because that's always like HTML breaks and things like that. And then replace abbreviation is another good function that I just discovered fairly recently. AM gets changed, A.M, instead of like after you remove punctuation would be 2 individual characters, it actually will collapse the 2 to A.M. So I like to use those as well. We're going to do the same thing we did before, where we are creating a corpus, sorry. So there's a couple times in this script where, because you remove stop words, if you're dealing with tweets, sometimes tweets are only made of stop words, and so you have to make sure that your data frames have the same number of rows, or you're going to cause all sorts of problems. Again, I'm going to do this live, but it could totally backfire on me. It's going to hang for a little bit, but I've taken this now cleaned Pakistan mentioning Guardian articles, and I'm going to do correlated topic models. It's different than LDA. Instead of the CTM, I could do LDA, but that takes a lot longer, so I'm trying to do just the CTM. And you specify K, which is the number of topics that I want to extract from it. So apparently something happened, but warning's a warning. We're just going to keep moving. Essentially what I'm doing is grabbing my topics. That's what this chunk of code is doing. And then I'm going to score. So once you have your topics, right, like we've identified 5 unique topics according to this correlated topic model. We have the original 5 articles. We're going to go back to those articles and say, what's your score for topic A, B, C, and so on. And you get an actual numeric probability of it being topic 1 versus 2. And then this next dimension that we're going to start measuring is polarity, and I'm just going to apply it to the text body, which is my 5 articles. This will take a while, hopefully not too long. I don't know. Maybe. So what it's doing is actually doing, for all 5 of those articles, or all the articles we pulled, it's doing that positive and negative calculation. Hopefully, may have gotten stuck. It's a good point, or a good place to stop. Questions to this point? Anyone?
Do you need to do sentence split before you do polarity numbers?
No. The question was, do you need to do sentence split before doing polarity? It's actually not looking for sentences, like syntactic parsing, which we'll do in the next script. So it doesn't matter. It's literally looking at unigram tokens. Yeah. Okay, so it looks like the sentiment's done. I'm going to bind it all together. Right? Then I'm going to create my tree map. See what it looks like? Well, it didn't render all that well, but you get the point, right? So the topics are actually overlaid on top in gray. Those are the words making up the topics. The lower, excuse me. Okay, sorry about that. Just a speaker emergency, I guess. Yeah, so again, it didn't render all that well because whatever, I don't know, I'm on a giant projector in front of 100 people. So each article is represented, in this case, by the mini blocks. The topics are the bigger blocks. This will look nicer on your computer, I promise. And then the color is actually the sentiment. So what you get there is a sense of positive or negative and how much people are putting effort into it. If you do this for customer surveys, it's really cool because someone who writes a negative survey who says this stinks and that's it, yeah, it's truly not good, right? But they're not putting too much effort into it. But if it's a long diatribe and you've identified a long negative survey, it may be worthwhile to see what the topic is underneath it. Let's see. Okay, and then the even uglier version is the automatic one. Again, I like to try and use custom palette or non-custom palettes like GG themes. So Portfolio has just map market, and you just pass things into it, and it will lay it out using this kind of ugly palette. But essentially, it's the same information. So I'll go back to the PowerPoint. So hopefully, it'll clean it up a little bit. You guys can. Okay, so this is Pakistan, the same ones, right? So this, on the left-hand side, you see some big articles that are super happy about this guy named Cook, who's an English cricketer, I think. And then you see over here, lower right, there's Taliban and some, so they're not spending too much writing time on this sort of thing. Interestingly, New Zealand and Australia cricket is split, so there's, I guess, a positive and negative article about it. So that, I find tree maps to be, they take a little explanation when dealing with stakeholders, but they're still very worthwhile. Here's that same information using the map.market, which is fast. You don't have to specify anything, but it's definitely not as pleasing. So let's go back to this for the last script here. So we've done, to this point, all of this kind of basic analysis using the methodology that works, right? So this next one, this last script, we're going to do syntactic parsing. In fact, one of the things I think is interesting in syntactic parsing is named entity recognition. We will be using the OpenNLP project package out of R to do it. So we actually have to, so syntactic parsing requires what's called part of speech tagging. That's where you're identifying, yes, this is a sentence, yes, this is a noun phrase, this is a verb phrase, and so on. It's tagging it down. And then further within that is a part of speech for named entity recognition, persons, locations, and organizations. So let me go ahead and go to this last. All right, so I'm grabbing that same corpus of documents. Hopefully it's returned the same. Or you can do it using read.csv. So I put both in here. Don't actually do one or the other, don't do both, because if you do both, you'll just overwrite the first one from the Guardian, right? So we'll, actually, you know what, let's do the Chardonnay one. I know what to expect out of that one. So here we're going to do that same pre-processing. And here it's important that actually you're not doing the transformations, because that actually will reduce your accuracy. So the OpenNLP is going to be looking for capitalizations to help it identify proper nouns for named entity recognition. So if you make everything lowercase, it's going to reduce your accuracy. So essentially what we're going to do is create our persons annotator, our locations annotator, our sentence, organizations, and part of speech tags. So we're going to create all of those. And then we're actually going to apply them. Maybe not. Let's see. Hold on. Sorry. Uh-oh. Well, trust me, it should work. Let's see. Not sure exactly what the issue is, but it's actually looking like there's a class problem. So what I'll say is, I will trim this code up when you guys download it, but essentially what it's going to do is go through this, all of these documents and identify both the sentence, the part of speech it is, and these different persons, locations, and so on. And then I'll show you actually what gets produced at the very end. Is actually, in this case, a list. I did it for Chardonnay on this one. So you get a list of all the named entities that it's found within the Chardonnay tweets. In this case, it'd be Marvin, Marvin Gaye, Leeds versus Sydney. You see a lot of Marvin there. Locations, you'll notice it does get some things wrong, like Rainbow is not a location, but Jerusalem is. I don't know what La Petite Ferme is. And then organizations, sometimes it's getting it right. Chardonnay, it clearly didn't get right. And so it's important that if you do named entity recognition, you understand that these are mathematical models that are trying to be applied to very dirty text, and it will very often get it wrong. But it's still worthwhile to do, and sometimes, like in legal proceedings, you could extract named entities if you have many, many thousands of pages you have to go through. So I don't know why I failed. I don't really feel like dealing with it live. So I'll stop here. That's the link to go get everything. What I will say is, first, I'll go trim up that one. So give me like half an hour to figure out what the issue is. Any questions at this point? Yes?
If you have a document that is not in English, outside English, other languages,
I've seen, okay, so the question is if you have a non-English language, what do you do? You can specify your location, so we helped a client in Japan. Not you, Matthew, a different one. Yes. We helped a different client in Japan, in which case you had to specify and tell R, like, deal with it that way. Bag of words is very difficult in other languages, especially character-based ones like Japanese. One interesting thing I have used in the past is Google's Translate API, where you are relying on the Google Translate API accuracy, but essentially it ports it all over into English, and then you can model it from there. One second. Yeah, you have
Yeah, you mentioned something about QDAP being able to customize that?
Yes, like the polarity function.
Yeah. I was wondering, like, how...
I think, and I haven't done it, but my guess is there's a data frame or a vector of new terms you have to pass in. Yeah, what I would do is actually load QDAP, do question mark polarity, and then go look at the function parameters, because it'll be in there. Yeah. What's up?
STEM completion.
Yes.
It takes more.
Yeah, man, I actually...
Can you navigate this not to be faster, or?
No, it's... I mean, I just go rent a DigitalOcean machine for $1 an hour that has 64 gigs. I mean, STEM completion is a pain. I try to stay away from it. I actually try not to do STEMing at all. That's just me.
Your statistics will be different.
Skewed, yeah, absolutely. But again, my approach is not to be, is to be more practical and to get to a point where I can talk to vice presidents and say, look, likely and like are both in there or whatever, right? So I don't have to STEM complete. I just find that you can cause problems and then you're just stuck. You have to like let it run overnight or something crazy. So, or just choke, right? It just stops working. Oh, okay. So yeah, I try not to do. I know that's not a good answer, but that's what I try and avoid it. Other questions?
Have you tried to do any domain-specific things like look within like a Stack Overflow where only technical articles are?
I have not. It just doesn't interest me. I use Stack Overflow a lot, but I haven't like analyzed it to say like, oh, generally people in R are asking questions about data frames or whatever. I have not. I try to stick. When I was at Amazon, we looked a little bit at social media during some launches in Europe, and then at Liberty Mutual, it was all like customer-facing, non-technical, and then we did a project for HR that I mentioned, so nothing technical. Yeah. Cool. Other questions? Cool. All right, thanks everyone.